Swayam Prabha. Digital India. Educated India.
Hello everyone and welcome to a new discussion which we are going to do today on integration of DEMs with the satellite data because as you know that though DM and satellite data both are raster and as DM is a storehouse of information or several derivatives which we can derive which we would be seeing in subsequent lectures, and satellite data are also a storehouse of information, lot of information, and depending on what area you are going to cover, how much area you are going to cover and what spatial resolution you are going to cover, all kind of choices are available. And nowadays tens or maybe hundreds of products based on satellite data are also available. One of the most popular satellite data product is DM itself. So therefore we need to integrate many times the satellite data with the DEM to see things in 3D perspective or make a representation of the terrain in more realistic manner rather than a bare digital elevation model. So from that point of view the integration is very much required. Both are raster except one major difference that is the value of this cell value or pixel value which is differently, otherwise both are raster, and therefore many times or most of the times I would say the integration of DMs with satellite data is rather easy. But it is very important, and because satellite data through this remote sensing technology is really providing lot of products or which we can ourselves also generate and can use in our GIS platform. In the demonstration which will follow after this discussion, I am going to also demonstrate how you can handle satellite data quite easily on a GIS platform. And the platform which I am using for demonstration is is ArcGIS. That never means that I am promoting that one, but that is the platform which I am using. You can try the same thing or same steps which I have been demonstrating on this software on like QGIS or other GIS products. So there is only what you have to understand here is I am only discussing the generic form of GIS, and for demonstration I am using one of the platforms of GIS. So at your end if you do not have ArcGIS, that does not mean that you cannot work. You can equally work or sometimes even better than what this software provides. So there is no issue about this, and only thing that tools are there. You have to find many times your own way to maneuver within that, select an appropriate tool and do the processing. Now why this DEM satellite data integration? Basically this as you know that data integration involves basically combining various data coming from variety of sources as per our definition of GIS also, that here the data comes from variety of sources, and then we would like to integrate them so that a combined product which we can generate using these DM and satellite data can be very useful, and people are doing on a regular basis by combining the data. So the most common, as you know, the digital data form, that is the shapes of the earth, is cell based elevation model which is there. One of the examples of data integration, especially particularly with DMs is satellite data, is the Google Earth. So which is in the background it is having digital elevation model, and for draping they are using this satellite data of various resolutions depending how zooming you are doing. So, when you zoom in, then that means you are going for higher and higher spatial resolution data. When you zoom out, then you may be seeing a relatively lower spatial resolution data. Further, as you know that in case of remote sensing, various satellites are there. Most common one are these polar orbiting or sun synchronous satellites, like that series started with Landsat, our own IRS, or a SPOT, or even NOAA HRR and NOAA series of satellites, and MODIS satellite, and there are many such satellites which are polar orbiting satellite. So, typical remote sensing is done with polar orbiting satellites. But as you know that this technology has improved very significantly in last 2 decades, and therefore now like geostationary satellites also can provide very good images or data source, though they are snapshots. For example, if I give example of INSAT series of Indian geostationary satellites. So, they are now, earlier they were only meant for communication. Now, they are also having a camera, a very high resolution digital camera, which can cover the entire India and subcontinent in just one snapshot. And also these platforms, geostationary platforms, are being used for various purposes. Even these geostationary satellites are now being employed for navigation purposes. So, this IRNSS, which is Indian this satellite system, or in short we say NAVIC, that Indian regional satellite navigation system, or NAVIC, which we are using for these geostationary satellites for navigation purpose also. So, these are basically multi-purpose satellites, the mainly geostationary, whereas polar orbiting satellites are having mainly one agenda, and that is acquiring images relatively at higher resolution. So, these satellites basically provide the raw data or raw radiance images, and which we make use of them, and nowadays tens of satellites of different countries are in orbits. Many data, especially relatively comparatively coarse resolution data or medium resolution data, say up to even 15 meter or 12.5 meter, it is available free of cost, and upward definitely. But if you go for say 5 meter resolution data, then probably you have to pay money. So, I always say to my students in IIT Roorkee that start using whatever available free of cost and try to exploit that one. There are one other hidden advantages with using this raw data is that if you claim anything, and later on somebody would like to check how you have used that thing and which data you have used. So, they too can perform the similar identical analysis at their platforms. But if data is not free, but then people cannot compare or check on your products. So, that is the advantage of also using satellite data. You provide a sort of a challenge that I have done like this. If you want to do it, follow these steps, data is available free of cost, do it yourself. So, that is another very good part of free data set. Now, as you know that GIS is a platform basically which provides the tools technology to integrate various types of data, which is coming from variety of sources, not only the vector data, but raster data like satellite images. So, it is a wonderful platform from that point of view, from data integration point of view, and of course, analysis, and finally at the end of the day one always try to go for modeling or prediction. So, this is the most appropriate platform for integrating especially this spatial data, and GIS has, as you know, has evolved by linking number of discrete technologies which were lying in isolation, and I can give a name of the technologies like digital image processing, like CAD/CAM technologies, or many mathematical concepts which were there, but GIS have started incorporating it, and this is how it is progressing, or this is how it is evolving. So, when we employ all this technology, whatever is available best in other domains, and if it is useful in GIS purposes, then people are integrating this technology. So, this technology in every day it is becoming enriched with the other technologies which were in or discrete technology or were not integrated earlier. As you know, as we have just discussed, that GIS provides platform to integrate spatial data and methods, because this is what I was just mentioning about methods, algorithms, concepts which are in other domains, especially in like mathematical or computer science domain, are being incorporated, integrated into the GIS, and that which will provide ultimately the better spatial analysis, and you can generate maps, different kind of overlays, and new types of analysis also becomes possible, and ultimately then you go for modeling, and that is beyond the capabilities of other methods, other manual methods, or on any other platform. So, GIS is the only platform which can provide modeling for spatial data. That is the unique thing about this thing. I have already mentioned that like Google Earth is one of the best free satellite model of the earth, which is the unique platform. Not only it is integrating digital elevation model and satellite images, but various other data sets, but the major one are these two digital elevation models and satellite data. Using Google Earth, people always look for landmarks, different landmarks which are present on the surface of the earth, and for entire earth you can study sitting in front of your system. So, Google Earth also allows to see very popular landmarks in either 3D, and this 3D is nothing but it is coming through the integration of digital elevation model with satellite data. So, this 3D perspective view or fly through view which you get on Google Earth is a beautiful example of data integration, and that is DEM and satellite data integration. Now, Google Earth is a custom designed GIS product, and it is mainly meant for spatial data integration. Google Earth is in the background, it is having SRTM 30-meter spatial resolution data, and top of this you see the satellite images of various satellites, Landsat, all images are free, Sentinel images, these are also free, MODIS images are also free. So, it is a platform basically which has integrated DEM with satellite data for entire globe in order to study landmarks, or many studies are now coming there. Even in the school, children has started using Google Earth in their civic or geography classes, and many other data sets have also been integrated, or you yourself can integrate by converting them to KML or KMZ files through even any standard GIS softwares. So, you can see the demographic, you can see the weather, even earthquake data, latest earthquake data are also plotted automatically if you would like to see road network, rail network, all this information, as whatever the information which you see on Google Map can also be seen on Google Earth. Now, main purpose of integrating digital elevation model with satellite data is to have a 3D perspective view, because a bare DEM without features of the ground cannot give you the full feeling of the terrain. So, for that purpose we always go for integration with satellite data, this DEM, and our GIS platform allows to grab these images like in Google Earth, Landsat and Sentinel images, or even you can grab the vector data like locations or earthquake locations or city locations or demographic data or any other such data sets, and over the DEMs. So DEM is always in the background of Google Earth, and this high quality 3D animations which are being created on maybe on Google Earth or maybe on GIS platform or on some other platform, but in the background they are having a digital elevation model. And for draping, you may have a satellite image, you may have a if it is a 3D animation of a animal, then you can have a a skin as a image, and a beautiful 3D perspective view can be created. Here we see one example of the 3D scenes and how these can be used. Another advantage of involving computers is that we can increase the vertical exaggeration of the terrain. That means that we can increase the scale for vertical compared to horizontal, because if we keep the same scale for horizontal and vertical, we may see something like the terrain like this. But when we increase the vertical exaggeration, that means I want to exaggerate the Z scale compared to my XY scale, then you may see terrain like this. It depends for what you are going to use it. One has to be very careful while increasing this vertical exaggeration, because this is not it is not giving the real picture, it is exaggerating things, as name also says, exaggerating. In Google Earth also you can exaggerate, that means vertical exaggeration you can introduce and can see. So this is very useful if you are going in a flat terrain like in a desert area or in Indo-Gangetic plain, and still you are looking the undulations or ruggedness in the topography or whatever the ridges or valleys or depressions, then vertical exaggeration can really work very well for flat areas, plain areas or desert areas, snow covered area. But doing vertical exaggeration for a already highly rugged terrain like Himalaya may not give you a great help, though it may bring some confusion. So one has to be very choosy, judicious while going for vertical exaggeration. This is one of the examples of how like in the background what you are seeing a digital elevation model, and top of this you are seeing a satellite image, and the 3D perspective view of a terrain is being presented here. This is very high resolution satellite or data provided by this satellite, and that is Pleiades, and this is being used for urban mapping and other things, especially for creating 3Ds. So this is especially launched for that purpose, where you can have a very high resolution digital elevation model of 0.5 meter. Earlier it was never thought, but now it is possible to do it with satellite images. Now this example is from Google Earth, as you can also see here, and this is 3D perspective view. When you tilt that one image or the symbol which is on the top right corner generally in Google Earth, you can see a 3D perspective view. You can rotate, you can tilt whatever you want, and this is what the Haridwar looks in 3D perspective view, and the surrounding area in Uttarakhand. So if I want to see, like this view is basically looking from south towards north, but if I want to change my perspective view say from east or from west direction, still I can see very well. Now why to prepare these 3D perspective view by using our own data sets on GIS platform or use these Google Earth platform for 3D perspective. The purpose here main is to study the terrain, landforms of the terrain, characteristics of the terrain, and get a feeling of the terrain if I am going to visit that area. For example, here a geologist will see completely a different way. A civil engineer will see this 3D perspective view in a completely different way, and a person who is interested for climbing or other things, mountaineering or other things, they will look differently. So the same perspective view, same 3D view can be used differently by different people. A geologist will try to interpret from structural point of view or from stratigraphic point of view that like how they are rocks are oriented, and is there any fault, like I know that there is a Ganga tier fault which goes roughly north south, and it has broken these Shivalik hills which you are seeing here, and has allowed Ganga to flow in between. So depending on what somebody is looking, if a civil engineer, he may, and if he has to find a place where a new bridge can be constructed, so without basically or before going on the ground, a study can be done initially for feasibility purposes, or feasibility study can be done using whatever available like a Google Earth. And once you have broadly identified a location, then a detailed view can be generated with high spatial resolution and high digital elevation models for that particular area where further study can be done. So for detailed project report or DPR, ground surveys may be required, or this new satellite data like Planides can be used because it provides at 0.5 meter resolution. So in that way data can be used, but initial or feasibility study can very well done based on 3D perspective views available on Google Earth, and this is what people do. A pilot will look Google Earth completely differently because he has to take off or land. So he will, if he is going to in a territory where he has never flown, he will try to see the things, and 3D perspective or fly through these things, like these how he will move and where in this, which direction at what time, all those things can also be simulated using Google Earth. Another like if I am interested from groundwater recharge point of view, then I would look I would use this data a little differently, because let me give you some interpretation about these images. Though it is 3D perspective view, but still this is the what you are seeing is the quartz reef, and these are the made of basically mineral which is known as quartz. Now here from where one river stream is going like this. So if I am looking a suitable site to construct a reservoir for groundwater recharge or surface storage, then this site I would say is definitely very good, because I am already having abutment on the both sides, a natural abutment created by the nature. So only thing I have to block this part, and then I can definitely use that one. So here let me try again with a different color, like here what I am saying. So this is the ridge, and this ridge is continuing. So if I block here on the ground, then I can inundate this water in upstream side, like here which is shown here. So earlier people have must have either they have used the topo sheets or other things, but now we can employ satellite images, can exploit these quartz reefs which are hundreds which are running in this large central India part, Bundelkhand region in the northeast southwest direction. And if any drainage line or a stream, a river which is going across, then those can be blocked and can be used for groundwater recharge. So my purpose of showing all this is that these 3D perspective view which is coming through the data integration of DEM and satellite images can be used by different people for different purposes. So one or two purposes I have shown in the previous image of Haridwar. Here the purpose is completely different. Similarly, because once you have integrated one thing or another, you can integrate with other data sets also. It is not necessary that only you would be integrating DEM with satellite image. You can integrate one DEM with several satellite images even for change detection. This is that example is here. That in time how these things have changed. See here you do not see the river. This is where as I have been saying, it's a bare digital elevation model. It's a and a product is shaded relief model, which we would be discussing in subsequent lectures how to generate. So here you don't see the even presence of river, but if I bring a satellite images, not even creating a 3D perspective view, the shadow part I have already brought from digital elevation model, and if I bring a satellite image with 50% transparency like this, I get both the things without much distortions. See, I can do a integration, I can create a 3D perspective view, but if it is not really representing the true ground conditions, then it may be misleading. So always one should try to remain as close to as the natural conditions and still perform integration and still exploit those outputs. So that should be the purpose here, which you are seeing very clearly, that this Brahmaputra river is now clearly seen along with the whatever the undulations in the southern side of that river is there. This is in a glaciated terrain, which is highly inaccessible areas of the Himalayan terrain. This example is of course from Mount Everest, and climbers, when they go, they always try to see what is the best way to climb, and because 3D perspective view is available, they can exaggerate, they can rotate and change the scale, change the view, and then plan the things. Of course, for Mount Everest only 2 ways are known and established, and hundreds of people every year are climbing. But in other, somebody is interested for maybe lower peaks elsewhere, then those things can also be planned by this. This is a study about the glaciers. How in glacier study, very famous glacier of Malaspina, Alaska, and which is a completely fan shaped, which you can see like this is a fan shaped glacier, which is not similar kind of features are not seen in Himalaya. Our glaciers are more or less either in finger shaped or linear in fashion, but this is very unique, and this can be also studied in through 3D perspective. A real feeling you can get here about the glacier, and one more which is coming from this direction. So that gives you a real ground feeling even without going on the ground. But if I have to study on the ground, then I can plan my field studies initially based on these 3D perspective. Now another example I am having about how one can integrate and can solve a problem which is false topographic perception phenomena, and this is what we have done, and the satellite images on the left side is suffering from this false topographic perception phenomena, or in short we say FTPP, and this is a simulated this is the shaded relief model where the illumination source has been kept in the northwest direction instead of, in case of satellite, this illumination source is in the southeast direction. So here I have that is why I have used word simulated, and the terrain, so it is illuminated now from northwest direction rather than southeast direction, as happens in case of polar orbiting or sun synchronous satellites, which we have mentioned earlier. This is this satellite image of Bhagirathi Valley, which is a tributary of Ganga, and this is from IRS satellite, IRS list 3, IRS 1D, sensor name is list 3. And you can see that here you may feel that river is this blue line, river is flowing on the ridge, but when you see here without any surface features, you find that this river is flowing in the valley. So this is basically giving the correct perspective view, but this one is not giving perspective view because of it is suffering from FTPP. So this problem can also be solved by integrating these things, and this is what we have done. So that this product is from digital elevation model. So DM was used here, and of course this satellite image was also used there, and a new product has been generated which is not suffering now from FTPP. and the river can be seen as flowing in the valley. So, no false perception, a true perception of Himalayan terrain. So, many problems can also be solved by integrating digital elevation model and satellite images, because using digital elevation models you can create these shaded relief model, or in short we say SRM or hillshade, which can be exploited, because here while creating shaded relief model we can choose where my illumination source is going to be. Like in this case, illumination source with reference to north is 343 degree, 0.3 degree, and sun elevation, that is the height of the sun, is 49.2 degree. If this is what because I wanted to get rid of FTPP, so I have chosen this, which is just opposite, 180 degree opposite of sun azimuth here. But if you want to resolve some other or solve some other problems, then you may choose any angle and these two angles and can create a 3D perspective view like this. So, this is what you are seeing here. On the left, on the first left you are seeing a digital elevation model which is completely featureless, then or bare. Then you are seeing a shaded relief model or hillshade. So, illumination has been added with the direction from the northwest direction. This image is of course suffering from FTPP, where illumination source is here. After using this one and this one, a new product has been created where illumination source is here, satellite image is here, and of course in the background you are having shaded relief model or digital elevation model. So, a problem can be solved very easily by doing integration in a different way. I would also show you an animation where 8 images or 8 simulations have been created, and then all have been put in a animated form using a GIF file creator. And what you are seeing, this this white circle is basically showing the illumination direction, and when this white circle is on the northern part or northern hemisphere, you do not see this false topographic perception phenomena, and as soon as it comes in the southern hemisphere you start seeing that river is flowing on the ridge. That means it is suffering from FTPP. So, not only you can solve the problem, but you can convince using such simulated animations. One more I am having where instead of changing the illumination direction, I have changed the illumination source height. That means from horizon 5 degree to 90 degree, because this is how the sun moves in daytime also. So, it rises in the east and then it goes slowly above the horizon, and in the noon generally it goes overhead. So, this is what it is simulated here, that when sun is overhead your terrain is having the maximum brightness, and when sun is close to horizon you are having big shadows, especially in mountainous terrain, and this is how you see. Further, from false topographic perception point of view, when you are having large shadow you are having much more depth perception. When shadows are small, especially in the noon time, you are having less depth perception. So, what are the advantages? Many of advantages we have seen in between, but in nutshell the advantage is that you can create the 3D perspective view at desired scale and angle using a GIS platform, or if you do not want too much processing other thing, initially you can start for feasibility study your Google Earth, and later on then you can move for that. Removal of false topographic perception phenomena I have already discussed with you, and DM and satellite image simulations are possible, DM and satellite image animations are possible. So, lot of other applications which I have not listed here are there of using DM and satellite images in integrated manner. So, new application, new advantages we would be seeing in future also, because A lot of digital elevation models of various resolutions are available. Many of them are free of cost, similarly with the satellite images, and therefore this integration is happening on various GIS platforms or some custom designed GIS products like Google Earth. So with this I end this discussion. Thank you very much.